Hi, my name is Jerry Haskins, and I'm a solution architect at VMware with the Office of the CTO. I'm going to do a demo showing two separate tenants in VMware Cloud Director sharing the same GPU resource on a single host. One of the workloads is running Windows in one of the tenant environments, and the other is running Ubuntu in the other tenant environment. While these workloads are sharing resources, they can be completely isolated from one another using VMware Cloud Director. For some of the basics of the environment, I have deployed VMware Cloud Director on a different cluster in the data center. To keep this very simple, I have a single node deployed in vCenter that VCD is managing. The single node has a single NVIDIA Tesla T4 GPU installed in it. I've installed the NVIDIA VIB for the T4 on ESXi, and then set the T4 to shared direct for vendor shared pass-through graphic. I have then created a resource pool for VCD to use, which it will use to then deploy resource pools for other VCD tenants as they are created. You could also have VCD do this at the top level of the cluster if you prefer. I have also deployed an NVIDIA license server in the environment. So let's go into the VMware Cloud Director console. Here there are multiple organizations. For this demo, the Retail Food Inc. and the Telco Group will be used. Each of these organizations have VDC virtual data centers created, which are linked to the same provider VDC. There is an NVIDIA icon next to each of the organization VDCs. This indicates that the virtual GPU policy has been attached to these VDCs to use. You see the other VDCs managed by this Cloud Director instances are not GPU enabled. Let's look at the GPU policies. Here, I have already created a policy attached to a single node for this demo. Let's look at what a GPU policy consists of. First, it needs a name. Then you have to choose what profile on the GPU to attach to the policy. As you can see under the vGPU profile, there is an info icon. If you click on that icon, you can see it will not allow you to pick from a profile other than QNC. Here you would select the vGPU profile. Select the VDC provider for the scope. You could do placement if you had multiple nodes in the policy. Memory sizing, and then complete. There you have a new policy that can be attached to different organizations to use. Since there is only a single GPU in my system, and the VMs must use the profile with it, I'm just keeping a single policy in this demo environment. If you had multiple GPUs, then you could have different policies available. Under infrastructure resources, you can add vCenters for Cloud Director to manage resources on. Here you can see there are two different vCenter resources you can manage. These are then linked to provider VDCs in the Cloud Resource section. So that is the basic overview of the environment. Let's log in to an organization VDC and deploy a VM. I will start in the Telco VDC. In this VDC tenant, I have created a template of Windows 10 with the NVIDIA GPU driver pre-installed and configured the license server settings. So here I can create a new VM, give it a name, and then choose from a template. I will choose the template I created for Windows 10 GPU. I'll use the default storage policy and then enable vGPU on the VM. I then choose the vGPU policy. The memory is already configured. I'll set up the network. I'll have it connect. We'll use a VMX-Net3 adapter, and then choose my VLAN and enable DHCP. And now we could just click OK. While it builds the Windows VM, let's look at another organization VDC that is using the same physical GPU on the ESXi host. I have already set up an Ubuntu system in this VDC running a video surveillance program called Chooch. Here you can see the vGPU profile is attached to the VM. This VM has some post-deployment setup done with adding Docker and then the application containers. So I've staged it for the demo. The deployment template can be created with NVIDIA drivers pre-staged on Ubuntu, just like for Windows. I will log into the host and inspect the vGPU is present and the application is running. Here, if I run NVIDIA SMI, you can see the vGPU driver is present. And if we run Docker container ls, you can see the containers for the application are running in Docker. This is a SaaS product, and you register it in the Chooch portal. Here you can see the application is registered and connected, showing the T4 GPU is being used by it. And on the local site, you can access it and monitor connected video streams. Let's go back to our other VDC and look at our Windows 10 deployment. It looks like it is completed. Let's look at the computer resources. Here you see it is attached the vGPU profile to the VM. If we go into the NIC setting and grab the IP, I can log on and inspect the vGPU is functioning here. I can go into the device manager and look at the display settings, and we see the T4 is installed. If I open the NVIDIA Control Manager, you can see the GPU registered with the license server. And if I log into Steam, can open a simple GPU application. There, SteamVR, which has GPU dependencies, is running and waiting for a headset to be attached. So as you can see from this demo, we have two different organizations in VM Cloud Director sharing the same physical GPU on a host, running different OS versions on the VMs, but can be isolated from one another. The new vGPU functions of VMware Cloud Director gives a simple deployment method for organizations to have quick access to virtual GPU workloads for their VMs. I hope you enjoyed this short demo with virtual GPUs on VMware Cloud Director. Thank you for watching.